Hello, I'm Robbie Clark. Welcome to my workshop. A few years ago, I was visiting the Midlands Model Engineering exhibition and bumped into an old friend who is also a member of a photographic society I belong to. We were both quite surprised to see one another there and didn't realise that we were both keen amateur engineers and had workshops at home. We walked around the exhibition together for a while, and my friend explained to me that some time back he'd bought three kits from Hemingway Kits. Hemingway's a very well-known company. They make a lot of kits for making tools for the workshop and special attachments for lathes and so forth. He told me that he'd only started making one of the kits and didn't sort of carry on with it. For whatever reason, he decided not to carry on making any of them in the end, and he asked me if I'd be interested in having the kits. Well, very, very keen on the idea, and said I'd be absolutely delighted to have them. So I gave him my address, and then in due course the kits arrived through the post. I have since then made all the items, which you'll see here in a moment. When I've met him at various society meetings since then, I've either taken items along or shown him photographs of the completed items just to prove that these kits were not wasted in my hands, and I did make every one of them. The first one I made was this one. Hemingway called this a set-over centre. It's a device for making tapers on the lathe, and instead of using the set-over device on the tailstock of a lathe, this can be set on the crossover tool. When you use the set-over device on the tailstock of a lathe, it's quite a task to reset it back into the zero position again, so this is really a preferred method. The method for setting the set over is you have a little calibration here with a centre position, and by releasing these little screws you can turn this one across or equal in the opposite direction, and that will move the front portion of the tool across to give you the particular angle you need to turn as a taper. There are two centres that you make in the kit. These are made out of tool steel. There's here a half centre and a full centre. Half centre is ideal because it means you can bring the lathe tool very much closer to the work. I think the kit normally suggests that you make the little knobs here out of steel, but I opted to make these out of brass. I thought they just look a lot neater in brass. By the way, all the kits are supplied with all the materials required to make all of the various kits, and the kits come with very, very good, easy to follow plans and build notes. The second item is a centre height gauge. This is the only one that my friend actually started making. The base of this is cast iron, and that's the only parts he'd actually made. I don't really know why he didn't sort of carry on with it. He may have just lost interest in making them, but I certainly benefited from that. This is used for setting the centre height of your lathe tools. On the column here you've got two devices here, with gauges which can be adjusted to various heights and locked into place. They put two on here so that you can either use the base on the bed or ways of the lathe, or onto the cross slide of the lathe. so you can set the tool for either of those positions, whichever is the most convenient to use. I guess if you had a small and a very large lathe, it might be possible to have one of these set for one of two different lathes. Whenever that's possible, I'm not sure, without these two gauges clashing with one another, but I guess that's is a possibility. This is the one tool that I use a lot of the time. Ever so often I'll go through all the lathe tools and just check and reset the tool heights as required. I mean, occasionally I have to replace lathe tools in holes, and I have got a lot of quick change tool holders available anyway, but sometimes you just run out of them and need to put a special tool in, so you need to sort of quickly set a new tool height, and then when you replace the original tool, reset that again. So that's a very, very useful tool to have. There's lots of different ways of doing this. If you look on YouTube, you find all sorts of different ideas on making a tool height gauge, but I think this one is extremely neat, very, very well designed. The third tool is this one. This is a cross drilling jig. It's designed to go on the lathe in place of the tool holder of the lathe, and it fits onto the stud that the tool holder is normally attached to, which just drops on the tool stud and then is locked in place with the locking nut. It's designed for drilling holes either in round bar or tubular bars, and the bars are held in position in this V slot here. The V slot will hold material from 1/8 to 1 inch diameter. There's a hole also drilled through here, goes right the way through the block here, obviously to give clearance for the drill. The drills are held in the lathe chuck, and to adjust the position of this and to bring the materials up to the drill, you're using the lathe carriage to move this in and out to the drill. This device here is a guide which can be moved in and out and locked into position according to the diameter of the bar stock that's being used, and then locked in place. And you make some guides for the drills. There was enough material in the kit to make 3 different ones with different diameter holes in them. These drop into this hole here and are locked in place with a little Allen screw. The kit advised, I think, 3 different imperial sizes to drill these two, but if you wanted additional sizes or metric sizes, you could just supply your own bar stock and make extra ones up. Now, if you're drilling very, very thin diameter material, that's obviously going to drop right into the V groove here. And with a larger bar stock, you have got this clamping device, which can be put over the bar stock and then clamped on, and that can be locked into place to hold the bar stock in position so that it doesn't move while you're drilling. Now, with very thin material, that's obviously a bit of a problem, because it's going to be right in the bottom of the V groove here. So another thing you make in the kit is this. It's a solid bar stock which you drill a hole all the way through here, and a hole across the material as well, and you have a thread on the back with a a locking collar here. Now that's pushed through the hole at the back here, and that will go into the V groove. Thin material is then pushed through the V groove, through this hole, and then by adjusting this screw it pulls the thin material down right into the V groove. The hole through here is obviously a clearance for the drill when it goes through that thin material. So that's quite a useful thing if you're drilling very, very thin diameter materials. This device on the end acts as an end stop. If you've got to drill a lot of material with a hole near the end of the material in the same position every time, to very accurately set that, this can be locked on the end here, so that when you pass the material through, it comes up against the stop and would set the material accurately in the same position every time. Now the other thing they suggest you can use this for, as the block here is machined on all sides, this is a heavy piece of cast iron. Actually machining all that took quite a long time to do. I didn't do this on the milling machine. I actually set this up in a 4-jaw chuck on the lathe and turn that on the lathe to get nice finishes to all the surfaces here. But the suggestion is that you can lay this on its back on a bench drill or drill press, then use that to hold material below the drill chuck on a bench drill. Very, very good idea indeed. Now the only other sort of slight problem is that when you're using this on the plate here of a bench drill, is getting this in the right position so that the drill is going to come into exactly the right position in relation to the bottom of the V groove. Now I'll show you a very, very easy trick to do this. It's something that I learnt from another YouTuber. He's a British engineer, who's spent a 40-year lifetime as an engineer, and when he retired he moved to Australia. I was supposed to live his retirement in the sunshine, and his name's David Ticehurst, and he's put a lot of very, very interesting videos on YouTube, lots of engineering tips on all sorts of setups and methods of drilling, which obviously he's learnt from years as an engineer. Now his suggestion in setting up something like this underneath the drill truck, the method he was showing is actually using a V block to hold the material, clamping material into a V block and making yourself a little device like this. This will fit into the drill chuck, and you cut a 45-degree taper here, so it looks like I don't know what, a little cone I suppose. So being at a 45-degree angle, it's the same angle as the V groove here, and you can let's probably remove this part first, but with that below the drill chuck, you move this around until that sits exactly into the V groove. That will put it exactly in the right centre. Once you've done that, you just use a clamp to hold the block in place. In this case, obviously you'd want to mount this so that it goes into the V groove above that hole, so the drill will pass all the way through. I mean, such a simple idea, but in practice it works very well indeed. Looks actually like a countersink without any flutes on it, but there you go. Very, very easy way of doing this. This is such a useful device to have. I've used it quite a number of times on the lathe. and it works fine. I have made another device which I'll show you another day for cross drilling on the lathe, something which a lot of people on YouTube have shown on their videos, but I'll show you that on another day. It needs a bit more time to explain. But anyway, thank you very much for joining me again in the workshop. I hope to have some more videos to show you very soon. Thank you very much for joining me. Bye bye now.